Thank you everybody for joining us. This is the session on working with maps online and offline. My name's Will Crick. I'll be doing the slides and the talking. I'm joined by Justin Colville, who'll be doing most of the demos. And we're morally also supported and joined by Euan Cameron, who's helping us from the sidelines, let's just say that, and also working on some other slides for tomorrow for another session. So he is here.
Or you could just choose to have Euan do all of this, and Will and I could sit down. We could
vote on that. That. Okay. So a few familiar faces in the audience. Hopefully you've noticed that we've kind of changed the way we're doing our sessions this year for runtime sessions, and that we're doing a lot more kind of cross-platform, well, not cross-platform, slightly the wrong word, cross-product sessions where we're not focusing on just .NET or Android. We're basically, because the capabilities are the same and the API is the same, we're more focusing on the workflows, the user workflows and developer workflows that you want to achieve, and talking about them in broad terms that can cover all platforms. So this session's about working with maps online and offline, but there have been a bunch of other sessions in the same vein for things like working with your portal, user experiences. We're going to do an editing session tomorrow. Analysis, building 3D, things like that. We still do have the platform product-specific sessions for .NET and Android, each one, for a deep dive into those and the demo theaters, but most of our effort this time has been focused on building these kind of cross-product sessions, so hopefully you'll appreciate that. Feedback, very welcome on that approach. Please put your feedback into the app and let us know what you think about that. So this session's working with maps online and offline. The agenda, we're going to go through what the mapping capabilities are with Quartz version 100, talk about the different workflows associated with working with maps online and offline, talk about where the maps come from, how you create them, and how you work with maps, and then going into a bit more detail about the offline workflow and talking about how you work with offline layers and how you create and bring them to life in your applications. There's going to be another session tomorrow. We actually did switch the sessions around at the last minute. I don't know whether that confused anybody, but so today's working with maps online and offline, and then tomorrow, I think at 10:30, there's a session on specific to editing and sync online and offline as well. So we kind of split that up from previous years too. So let's just talk about what the general capabilities are when we talk about maps and scenes working with Runtime version 100, which we released in November. So general capabilities are you can work with web maps from the portal and you can open those. You can create new maps in your applications using online and offline layers. And once you've created those maps in your applications, you can save those back to the portal to share them with others as well. When you do save, we'll talk about that in much more detail in this session, but when you do save, we obviously only can save those compatible layers that the portal works with. From a scenes point of view, the story is slightly different right now. You can't open web scenes, but you can create scenes in code. So you can new up a scene and add an elevation source and add your layers and view those scenes in your applications, but you can't quite yet save those back to the portal as web scenes, and you can't open web scenes just yet. That's something we're working on for future releases, and we'll be able to, hopefully next year, give you a full deep dive session in that. So this session is really focused on the 2D side of maps. The 3D session will go into working with scenes in a bit more detail. So those are really the kind of very quick overview of where we're at right now with working with maps and scenes. So when you are working with maps and scenes, you can add in layers. And right now, because we don't have the capability of taking a map offline for you easily, you as a developer have to work with the layers themselves. That's something we're working on for the current release we're building actually for update 1, and we'll give you a little bit of a sneak peek of that at the very end. So right now as a developer, you can work with online maps, and when you take a map offline, you have to go and take the layers offline yourself. So we'll talk about how you do that in this session specifically. But you can take the layers offline and you can also edit and sync them, and we'll talk about that in the editing session tomorrow. Other general capabilities of maps that you conceptually could think of, such as geocoding, routing, and analysis, also have other workflows for how you work with them online and offline, and we'll cover some of those today as well. So before we get into the details of kind of how you work with these things, we thought we'd cover some general connectivity scenarios that we support and what the general approaches are for you as a developer. So there's kind of four real connectivity scenarios. One is that you've got reliable Wi-Fi, good 4G coverage, and you know that as you're using that application, that will always be there and you can rely on it. Maybe it's an app for the office, or it's an app for the field, but you just know you're going to have connectivity. Obviously, if that's the case, it's a pretty easy decision to make. You can use the online layers. You could also choose to package up offline data if the data is small and you just wanted really good performance and it doesn't change over time. Then just because you have connectivity doesn't mean to say that you have to use the connected workflow. You could easily package up and provision your application with a mobile map package and use it as a completely offline. So for example, the Esri Events app that you use is an online app. But it actually uses a mobile map package for the mapping inside it. So it uses Esri technology, and they've actually packaged up a mobile map package of the Palm Springs Convention Center inside the application because it just makes it generally faster. They don't have to rely on any network connectivity. Even though they get probably guaranteed to have network connectivity, they've just decided from a user experience point of view, it's better to put a mobile map package inside the app, so it's still an option to you. So that's the connected scenario. If you have a connectivity scenario where you've got significant amount of times without connectivity, but some known times when you will be connected, you can start to think about an offline workflow where you either work with an ad hoc workflow where the user decides when they're going to take the data offline, or you can work with a bit more of a planned offline workflow where you pre-provision and pre-build these packages, and we'll talk about this a little bit later, but you can pre-build the packages for users to come and download at specific times of the day to then take out into the field. So that's quite a common workflow. That's really the collector workflow. You know, collector would never work if it didn't have a known point of connectivity where you could actually download the maps because it's not pre-provisioned with data. The user has to go and take that data offline. So that's another scenario to think about, and we have workflows for you to be able to work with those. And then there's the scenario where you never have any connectivity ever. So maybe it's a scenario where you need to pre-provision something to somebody on a DVD. They need to put it on their device when they're already out in the field, work with that, and you know that throughout the lifetime of the application, there's never any connectivity at all. For that kind of workflow, you need to be able to pre-package and pre-provision the data up into your application or onto a DVD that they can sideload, so they can basically work with it. So that is a desktop workflow where you'd use desktop to pre-provision the data, cook some packages, and burn it into the app for use later. And we'll talk about that in a bit more detail. And then there's the slightly awkward scenario that is a little bit unpredictable, which is the hardest one to deal with, but actually also quite common, which is slightly unfortunate. But this is where you may or may not have connectivity and you don't really know when you're going to get it. And in that scenario, I suppose you've got two options. You can either go with an online application with some client-side caching where you just accept the fact that at some point they might not see the tiles or the data that they want and just deal with it that way. If that's not a significant problem to you, that's perfectly acceptable. Or because of that intermittent connectivity, you might decide that, you know what, we want to play safe and we want to pre-package all of the data, and you could use the offline workflow, whether it be pre-planned or from using services, or whether you use the desktop pattern to make sure that that data is always there in the application. So it's a bit of a tricky scenario, but I think as an app builder, you do have to make a choice because those are the choices available to you and you've got to fall into one of those buckets. We don't really have a solution where you can do a bit of caching and pull data down and augment an existing cache kind of as you go along right now. But we typically find that most users can make a decision as to whether they're going to go with online data or pre-package their data up into their application. So those are the kind of connectivity scenarios, and the development patterns that we've got for you, which I'm now going to go over in a bit more detail. This is the easy slide, online workflow. You basically author your data in ArcGIS Online, or you optionally author your data in desktop and publish it to ArcGIS Online. And then features and maps are brought down to the client, and if you edit the map or edit the data, you can then push those edits back up to the cloud. Pretty straightforward. The offline workflow, where when you're working with services and feature services in an on-demand workflow, is where you author your map in the same way as you did before. You author it in ArcGIS Online. You then, actually, when you take the data offline, it's at that time that the data and the packages are prepared. So you as a client request for those packages to be built for you in on-demand manner. You specify the extent and which layers and LODs you want. The services back-end then cooks and prepares those packages, downloaded to the client. You can then edit them, and if you want to, you can synchronize them back. That's the services pattern on demand with using ArcGIS Online. You can do the same thing with using ArcGIS Enterprise, and if you want, you can also publish from ArcGIS Desktop, as you could do in the previous online scenario if you want to. And the rest of the workflow is essentially the same. So the services pattern, where you're cooking these packages on demand based on the client requesting them. And then there's the services pattern, but where you're pre-planning some of the packages to be created. And this is where there's a lot more work required on you to figure out the areas that you're going to pre-cache and what those packages look like. And then at the moment, you as a developer have to figure out how you store those and where you store those. Recommend you store them as items in the portal. You can do that. But in terms of synchronizing and keeping those packages up to date, right now, that's for you to build. And we have had business partners build this quite advanced workflow in the utility sector that's working very well, but it is a significant amount of work right now. We are working on trying to build this into the platform so that in the future, in ArcGIS Enterprise and ArcGIS Online, you'll be able to have this workflow where you pre-create some of these pre-planned areas in the portal, and we'll take care of keeping them up to date as your data changes in the back end, but that's not there right now. But it is still a valid workflow. Some people do find it a very valid workflow because it reduces the amount of server load, so that you can pre-create the packages once, rather than if you've got 100 clients, 100 people creating the same packages 100 times and putting a lot more load on the server. So this pre-planned workflow, for data that changes a lot, and when you're working with a lot of clients, then sometimes it's necessary for you to go down this path. And it is something we support. We have some information on how to do it, but as I say, there's a bit of work to do it properly if you're doing it with synchronized data. And then there's the desktop pattern, which is really the side-loading desktop pattern where you're pre-creating all of these packages, and then you're either using create runtime content or creating mobile map packages, and then you're provisioning them to the device for a completely disconnected scenario where that application and the life cycle of that app is never going to have any connectivity. And that's something you can do with Pro and mobile map packages or ArcGIS Desktop and create runtime content. In terms of those workflows, when you're working with features and basemaps, as I say, there's these two kind of patterns. There's on-demand and there's pre-planned. This is really just a summary slide on what I've just talked about. But on-demand uses the server processing as the clients request the packages. The server has to create those packages, and there's quite a bit of processing involved in that. With pre-planned, it can help alleviate the load on the server, especially if everyone's doing it at 9 o'clock in the morning. Sometimes those servers can get maxed out. And some people use a combination of pre-planned and on-demand. They sort of sideload and pre-provision their basemap data, and then they use on-demand for the feature data and the operational layers on top. That's also a perfectly valid approach. We have these workflows that we help you understand, but it doesn't mean to say you can't take them and mix and match for your specific workflow. I suppose the most important thing on this slide is that the networks and the locators only have the desktop workflow associated with them. You can't connect to a network service or a geocode service and extract out a portion of that so it works offline. If you do want offline networks and locators, you have to pre-provision those inside mobile map packages or as create runtime content into your app beforehand. Okay, so let's look a little bit more detail into creating maps and how you actually work with maps. You can author your web maps in ArcGIS Online, or ArcGIS Enterprise, but you can also author web maps in ArcGIS Pro. And actually we see that some people need to author their maps in Pro if they're using advanced symbology and symbol sets where they want to actually use the kind of vectorized symbols that look really good on high-resolution devices. Then actually it's better for you to author that in Pro and then publish those web maps to ArcGIS Online. The advanced symbology definitions come through in those services that you publish. The ArcGIS Online viewer doesn't use that. It actually uses only the picture marker symbol representations of those. But when you load them into runtime, we actually do pull down the advanced symbol definitions and render them as vectors, so you should see them working and looking very good on the high-resolution devices. So if you are working with advanced symbol sets, then Pro and Advanced Symbology is the way forward for you there. In terms of the layer types that are supported in ArcGIS Runtime version 100 inside web maps right now, it's feature layers, tiled layers, and map image layers. We're working on much greater layer support in this update 1 release that we're building right now. But things like web tiled layer, OpenStreetMap, Bing, GeoRSS, CSV by reference, those currently don't work in version 100 when you're authoring your maps. You need to be aware of that. You'll just get them down on the client as unsupported layers in the API. So they'll still be there in your map, and if you edit the map and save it back, they'll still be persisted, but you just won't be able to view them in your application right now. But you will do very soon. So that was about authoring web maps. In terms of authoring mobile maps and mobile map packages, you do that in Pro. Mobile map packages contain the maps, the layers of those maps, and the data associated with the layers. Mobile map packages contain everything that web maps have in terms of a map, a base map, operational layers. They can, though, in addition to the maps, also include locators and networks. So you can start to include kind of networks in there for you to be able to do network analysis. A couple of things to be careful of when you're authoring mobile map packages in Pro is that there's a few things that are slightly different. So when you're authoring your map in Pro and let's say, defining label definitions, then the labeling engine in Pro is different from the labeling engine in Runtime. The implementation is actually different. So you'll see your labels being rendered in Pro, and then you'll open it up in Runtime and it will look subtly different. And if you're doing quite advanced label definitions and you really care about the precision of the labels, then you need to make sure you take care of that. We are thinking about and working on how we can make that experience better so that you get a better idea of what the labels look like right now. Maybe trying to incorporate the Runtime labeling engine inside of Pro so that you can see it straight away. But we're still working on that and figuring out how the best way to go forward with that. So just some of the things to be careful about. And best thing to do is to show you a demo of authoring mobile map packages so you can start to understand some of these workflows. So I'm going to hand over to Justin.
All right, number 3, please. Okay, so we're going to take a quick look at how you can package up your maps in a mobile map package to use inside of your runtime-based applications. So to author mobile map packages, we use perfect timing. At least it didn't force me to have to do that. I could have waited. So to author mobile map packages, we use ArcGIS Pro. And here inside of Pro, we can see that I have a start of a map. Has some wind turbines and some custom road networks. And as I zoom out, you can see that my labels turn off and symbology changes, and I can see that I have quite a few windmills here. But I don't really have much context with my map, so I need to add in some more layers for giving it some context. And to do that, I'm going to use layers from the Esri Street Map Premium dataset. So the Esri Street Map Premium dataset comes with a number of different base layers that you can incorporate into your map, but it also comes with a transportation network. And you can do things like augment it with your own custom roads. So you can see my yellow roads here are now integrated into the existing road network that was coming with the Esri Premium Street Map dataset. So now when I actually create my mobile map package, I'm going to be able to route off the commercial roads that I came with the dataset right onto my own custom roads to be able to route directly to wind turbines out in the field. So also in my project, I have a custom locator that was created for finding the wind turbines. And once I've finished authoring my map and put everything together, I can then use the Create Mobile Map Package tool to be able to create the mobile map package. If my project had multiple maps in it, I could actually specify multiple input maps, and all of their data and layers would be poured in for all the individual maps. And I can also choose the locator that I've created here as well. And now when I package up all of my data, I'm going to get a single MMPK file, a single mobile map package file. It's going to contain my maps, their layers, all their data in one thing that I can then either deploy to ArcGIS Online or my portal or sideload onto a device. So that's just a quick look at mobile map packages. Back to you, Will.
Okay, so that was general information on how you create maps either in ArcGIS Online web maps or ArcGIS Pro mobile maps. Now we're going to switch and talk about, once you've created those maps, how do you actually work with them in the API? How do you open them? So opening web maps, we've integrated it quite nicely into the API. So there's a couple of options. You can create a map from a URL, and that URL can have various forms. There are actually 3 types of URL when it comes to getting a URL for a map from a portal. There's the URL when you're actually in the map viewer, because that contains the item ID, and you can use that. You can get to the item details page. That's a slightly different URL, contains the same ID, but we've made it so you can use that as well. And then there's also the item data URL, which is actually the sharing/rest/content item URL that we would use internally regardless. That's how we go and get the data anyway. But if you happen to know that URL, you can use that too. So we've made it as easy as possible for you to be able to copy and paste a URL, whether you're in the web map viewer or the items details page, and use that in your application to instantiate the map. You can also use those same URLs to instantiate a portal item using our portal API, and then use a portal item to construct your map. So we've integrated the portal API and our mapping API so that you can search and find items in the portal, use that portal item instance and construct a map in the API. And here we have some .NET code where we're creating a portal, we're creating an item from the item ID in the portal, and then we're essentially creating a new map from that item and setting the map on the map view. And because we have this loadable concept where we load dependent objects, as soon as you set the map on the map view, because at that point we need to load everything, we'll set off the chaining of loading events. And if nothing's loaded, we'll load the portal first, then we'll load the portal item, then we'll load the map, and then we'll put the map in the map view for you. So you don't actually have to, when you're setting things on the map view, you don't have to load it. We do it for you. If you're worried about loading, then you can always call load, because there's no overhead in calling load on an object that is loadable. But in this case, you don't have to do it. We've kind of done it for you, which makes the code for creating a map and viewing it very easy. You as a developer can obviously create maps in code. The nice thing is if you're creating maps client-side in your application, you always have a map object, and that map object is exactly the same map object as if you've created a map from a portal item. So you've created a new map. That means if you save that map, we will save it as a web map. The map object is a web map, essentially. We use the same data structure and the JSON web schema to be able to serialize those maps. So whether you want to work with web maps or not, it doesn't really matter. You've always got one. So if you need to start, if you want to be able to save it to the portal to share it with others, you can do that very easily. Creating a new map in code is nice and easy. There's a various set of constructors. We've made it easy for you to create a new map with a base map. So here's .NET code are showing you how you can create a new map using the imagery base map. You can set a lat long of an initial extent or zoom location where you want to go to. This is using lat long and level of detail, which can construct a viewpoint. Easy way of creating a new map and zooming it to in your application. Once you've created a new map with a base map, you can start to add operational layers that live on top of the base map. And that's just as easy as working with the layers collection and adding or removing layers into that. In terms of saving maps back to the portal, once you've created a new map or you've opened it, if you want to edit it, you can easily call save or save as. And there's a little bit of detail I wanted to dig into here. So there's a property on the save as function called force save, which I suppose the reason we have it there is because we want you as developers to make sure you're opting in to realizing that when we save the map, we're only going to save data into that web map that conforms to the web map spec. So if you've meddled with the JSON, which you're obviously totally capable of doing, but if we find JSON that's inside that map that we don't support and doesn't adhere to the web map spec that we understand, we will drop it. And we put that property in there so that you as developers understand that when you save a map, you might lose some data. If you've added layers in there that are kind of custom, or you've added some of your own JSON in there, if you don't set force saved true, we'll actually error and we won't save that map because we'll say there's something dodgy in there, we don't understand it, we're not going to save it. So then you as a developer have to say, okay, I'm going to force save this map. I have to opt into that by marking that Boolean property to true, which means you've acknowledged the fact that you might lose some data. We're not going to tell you exactly what that data is because we don't have a nice way of actually giving you that information, but essentially you can look at the web map spec that's published in ArcGIS Online and you'll know that that's all we're going to save. If we have layers in the map that are unsupported, that means we know about them. That means they're in the web map spec. We know what type they are, we just currently don't render them. So a web tiled layer is an example of that. When you call force save to true, we'll continue to save that layer. We know it's in the web map spec, we know the JSON format for it, and we'll do that for you. So that's fine, you won't lose any unsupported data. But if you find unknown data in there, which is data that we can't find in the web map spec, but we found in this map, that's the stuff that you'll lose. And there is actually a way of you as a developer being able to inspect unknown and unsupported JSON in all of the JSON objects we support. So you as a developer can look at that JSON and find out what it is that you're going to lose. So if you're interested in that, there's the JSON serializable class has unknown JSON and unsupported JSON on it. So anything that's JSON serializable, you can go and inspect and look at what the data is associated with it. The other nice thing about that is if you open a map that's, let's say, using a later version of the web map spec that we don't support and we don't understand, you can still actually access that configuration data in that web map through the unknown or unsupported JSON variables. So let's say there's a new property that's added to a feature layer that tells you what, I don't know, what its name is, and you want to show that in the application. Even if we don't provide you an API for that, you can use the JSON serializable object, look at the unknown JSON, and it will actually give you all the data that was in that web map, and you can use that, parse it, and use it in your application as you like. So quite a lot of detail in there, but saving maps was non-trivial for us, and we wanted to make sure we did it robustly, and we've done it in a way that makes sure that we can guarantee when the runtime client gets saved to ArcGIS Online, we're not saving any dodgy JSON. One of the really good things that we added into the web map spec, which kind of forced us to that, is that we write the client that is saving that map. So if you do open a map in ArcGIS Online, you can actually see who it was who saved the dodgy JSON in there. And we didn't want that to be us, so we made sure that we did it properly. So I think that's actually a very good thing to add to the web map spec. It makes us all think about things a lot more deeply, which is good. So here's the save as method. Lots of properties in terms of this is a convenient save as method that allows you to save a map to a portal with a title, description, some tags, a thumbnail, and this force save parameter that I've set to true, so I know I'm going to lose any unknown JSON. And that's an async method. This is some Android Java code, and when that's done, you can get the result and say that it worked. So what I'm going to do now is hand over to Justin to do a demo of that.
All right, so first we're going to start by taking a look at a small little iOS app that allows you to either create new maps or edit existing ones. So here I have a blank map. I've already logged into my portal and I have a new map that I've created. And from here I could add layers to it and I could change symbology and do things, or I could actually open up an existing map that I've already created. So we're going to get this really well-authored map here, copy number 2 of it, and open it up and take a look at it. So simple map with one of our sample services there. And now that it's open, I can start to do some editing operations. Maybe I don't want the streets base map. I'd like to instead change it to use imagery. I can come over here, I can turn on and off layer visibility. So these are all properties of the map, things that you can edit in when you're authoring things in any of the authoring tools that Will talked about, ArcGIS Online or inside of Pro, that we can start to modify here. We can change transparency of those. And we actually have an experience where, as a developer, you can build changing the render that's used and changing out the symbology for your layers. I can also add additional layers to my map. So if I wanted to, I could find layers that are shared inside of my organization and add additional layers. And we can also modify things like bookmarks. So I can very easily create a new bookmark that then I can use inside of my map and save back to the portal. So once I have my map changes made, I can hit the save button, maybe. I can hit save. I think it's thinking. There we go. And it pushes all of those changes back. So let's jump over to Xcode. and take a look at a little bit of the code that was behind this. So the first thing that we had to do is we had to log into our portal. So I didn't actually show the login part of it, but this is where I can create a new portal object, and then it will prompt me with a default experience around my credentials and log me in. Once I have that portal object, one of the things that we did is we wanted to go out and retrieve all of the items for the particular user that I was logged in at. And with the new portal API, it's very easy to do that. I can just go and fetch all the contents for that particular user, and I can go through the maps and I can add them easily to a table view. And then once I had that table view that we saw, I chose a map, and that was very easy just to create a new map from a portal item, one of the constructors that Will had shown, and then set it on my map view. And then once I had that map open, we could do some of those editing operations that we looked at. So the map has a series of properties that makes it very easy to modify things. So when we went to go set our new base map, it was just as simple as setting the base map property to one of our new base maps that we had. Very similar for working with operational layers. The operational layers are just a collection on the map. So modifying that collection, I'm able to reorder things, I'm able to add and remove layers from the map very simply. And again, with our bookmarks as well. I could just new up a new bookmark, set some properties, and set my viewpoint, and then add it to the bookmark collection. And I realized I've gone into...
Lost in the code.
Yeah, no, lost in the navigation. All right, there's one more. Will?
Sure.
Any idea? How do I get back to...
No idea what you're looking for. Can't help you.
There we go. I don't use Xcode or Swift quite a lot, so I double-clicked where I shouldn't have. So the last thing we want to look at is our save code. So we have kind of two different scenarios that we could have ran into in this app, where we'd created a new map and we needed to do our save as, or the case that we went through is where we needed to do save. And I think Will was talking about the force Boolean that we have for it. I think Swift actually has the best. It's save with force save.
With
I think it's way better than just a little Boolean property that .NET has. But I don't know.
Probably put the in the name, shouldn't we?
That would have been yes, quite geeky of you, Will. I agree. So we could just simply, we called save because we had an existing portal item already, but had we created a new map, we could have actually called save as. And depending on, there's two different ways to do it, either using our convenience constructor where we can specify a subset of the portal item properties and have it create a new portal item for us, or we could have actually newed up a portal item as well, set a bunch of different properties, thumbnails, names, all the different kinds of things that the portal item support, and then did a save as with the new portal item and our new map. So quick look at saving maps.
Okay, so that's opening and working with web maps. Now we're just going to quickly talk about opening and working with mobile maps. So before we go into this, I'm going to ask a question. How many of you are building applications right now that, hold on, let me finish. Who's building an application right now that uses a web map? Okay, or and let's say who's building or planning on building an application that uses a web map? Same number of hands, okay. What about people who are building applications that will or do work with mobile maps and mobile map packages? Okay, so there's more offline people here than online people. That's good to know, interesting. So yeah, working with mobile map packages and mobile maps is very much the same as working with maps. Instead of using a URL to construct your map, you're essentially using a path. The only thing about mobile maps is they have this container around them, which is the mobile map package itself, and that has metadata and information associated with it that you can display and look at and inspect. And then inside that mobile map package object, there are one or many maps, and you use the same map class as you do working with a web map to be able to construct those. That is again because the mobile map is a JSON definition that is essentially exactly the same as a web map, with a couple of extra things in it to point to local data. So it's really just the layers have got a path attribute. But if you looked at the map JSON file and you compared it to the web map spec, it would basically be the same, couple of extra things. Here's some code of opening a mobile map package and loading it. It's a loadable because it has a lot of metadata inside it, and it might take time to read that off of disk, so we've made it loadable. And actually, the best thing to do is to show another demo where hand over to Justin again. Oh, yeah, I say hand over. It's actually on this machine.
Oh.
To show an application that uses mobile map packages.
All right.
Euan.
Up. Okay. It's a lot of demos. Getting kind of
good.
We've only got a few more. This is good. So this is the start of a new example app that our team is working on that leverages mobile map packages to show a series of maps and work with your data offline. So this is a mobile map. This app is powered by a mobile map package that we created with Pro, and this one actually had 3 different maps inside of the one mobile map package. And they had some shared data, so only that data was brought over once that needed to be, and they had some different symbology for each of the different maps. So I can open up these maps and get the same experience that we'd expect, hopefully. There we go. All of our pipelines draw in, and I can easily go back. I can open up another one of the maps, and we'll see that it's sharing all of the same base data, but then has some new symbology and some new data that's also included in the map. So this is really about kind of replacing that printed map book that would have been under the seat of somebody's truck with a series of maps to help them do their job. And it's something where with a mobile map package, you can easily have that data staged on ArcGIS.com or on your own kind of web server where you can go out and you can grab updates to those mobile map packages and download them. And that's what our little sync button does here on the top of the app. And we can actually go out and pull for updates of that.
Sorry about the quality of the display. It seems to have degraded somewhat. It looks
okay.
It looks really nice over here.
It looks great here, but let's go look at the code, because that's even, how about that? So this is just a quick, Will showed a little snippet of this, I think, already. So it's just really simple to be able to create a new mobile map package with the path of the mobile map. And then once you have that, you can easily go through and you can itemize the contents that are contained inside of it. And the thing that we were most concerned with here is getting our list of maps. So this is where it would return that array with 3 different maps in it, and then we can start to do things with it. For us, we created that view of the 3 different thumbnails. So we went through for each of the maps, we got an item from them, the portal item, and we can go through and we can pull out their properties and their
local item.
Their local item. Yes, you're right. Very well. Get their local item from them, and from there we can pull out properties like the thumbnails that we saw, their names, the dates that they were created, and that kind of stuff. So all very easy to be able to get the access to that information to build your UI with it.
Yeah, that's an important thing actually, that both web maps and mobile maps have an item property associated with them, which is where you go to get the metadata. So when we package up a mobile map package and we put maps inside it, we also package up a local item JSON definition, essentially exactly the same as a portal item definition with just a few extra things. So that does allow you to get access to all the thumbnails in exactly the same way as when you're working with portal items. So the code you write for your offline and online apps with working with portal items you can share, which is quite cool. How do I get out of here? Out of interest, that offline mapbook app, anybody want that app? Anybody building an app that's similar? Okay, good. That was the idea. That's good to hear. Okay, so that was working with maps, working with online maps and working with offline maps. Now, because right now we don't have a task that allows you to take a map offline, what we're going to talk about next is offline layers and how you as developers, if you do want to take maps offline, you have to work at the layer level. What are the types of layers you can work with, and how do you actually bring them down in these offline workflows? So the offline layer types that you can work with as a developer are tiled layers, and these are either packaged in ArcGIS Desktop and ArcGIS Pro into mobile map packages, or you can export those from a service. So you can use the export tile cache task, and we'll run through that in a minute. The other type of layers you can take offline are feature layers, and either through mobile map packages in geodatabases, mobile geodatabases from ArcMap, from Create Runtime Content for the offline versions of these, and then you can also generate these geodatabases using a task in the API. So what I'm going to do now, hand back to Justin for another demo of how you set up these services and the layers to enable you as developers to be able to take them offline if you're using the services workflow, which is exporting tile caches or generating geodatabases.
All right, so first we're going to start by taking a look at how we turn on the capabilities to take the data offline inside of ArcGIS.com. And here I just have two layers, a feature layer and a tiled layer, hosted, both of them. And we'll take a look at how we enable these for offline use. So let's start with the feature layer. And these are really hard, so you've got to make sure you guys pay lots of attention to this next couple of steps. That you go to settings, and you find the checkbox that says enable sync, and you have to hit the save button. Very, very tricky. So that's, and for tiles, it's probably it's just as hard. Settings, and go down to enable offline mode. So with both of those now, we have the capabilities to be able to, from our API, use the URL for those services and use the export tile cache task or the generate sync-enabled geodatabase method on the geodatabase sync task.
Nearly right.
That's, to take those features or tiles offline. So to continue on, we'll take a look at doing the same thing for ArcGIS Server. And we won't start with the base map because ArcMap's not responding. So we'll start with how we do this for a feature service. So to support being able to take your feature service on your ArcGIS servers offline, the data needs to live inside of an enterprise geodatabase. So we can see here that I have a data set that I've copied over and lives inside of my enterprise geodatabase. And to enable it for taking it offline, we have to make sure that our data has global IDs, and the preferred way of doing it is to have it archive enabled. We do support version data, but for scalability, and unless you have other requirements around version data, we recommend going with archive enabled data. So to do that, we can right click on our data set, we can go to manage, we can click Add Global IDs. And this should be relatively quick because the data is small. And then we can enable archiving from the same place. And once our data is set, so while it's finishing, a couple other things to note is if you did have any relationships or attachments for the data that you're using for this, they all have to be based off of global IDs. So if you had older data where you've added attachments that were based on, say, an object ID field as opposed to the global IDs, they need to be switched over to be able to enable them and use them with synchronization. So now that our data is enabled, we can go share as a service. And once we get to the right pane, we're going to enable feature access. So under the capabilities, we're going to enable feature access. And then on the feature access pane, we'll check the sync box. So if our data was version data, we actually have some options about when new versions would be created. So for anybody, is anybody using version data inside of their organization? So there's two different options when you're using version data with sync about when new versions will actually be created. And this is something you set on the advanced options. You either have a version per map or you get a version per user. And that's where the data will get synced back to, is that particular version that's created. There still needs to be some process taking it from that version and putting it back into reconciling that with the rest of your data. So this is just about creating a new version that the sync actually happens against. And from here, we can publish our service. So that would create our sync-enabled feature service. And now, if we switch back to this version, same kind of thing for publishing a tiled service. So this is a not particularly pretty base map that I'd like to publish as a tiled service with export tiles enabled. And I can go share as a service, but this time on the But this time, I want to be able to go to the caching pane, and I want to enable using caches. I can set using tiles from caches. I can set the LODs that I want to have cached, and what I need to do is I need to go to the advanced settings and the really advanced settings and click on the allow clients to export tile cache. So this is what enables that property, that capability on the new tile service that we're going to create. And then underneath of it, there's a way to be able to limit the number of tiles users can take offline. So there's a bit of a cost of actually packaging up all the tiles from the cache that lives on the server, and there's definitely some size requirements that you need to make sure you have disk space to be able to handle it. So depending on your services, depending on your use cases, you may want to either expand or reduce the number of tiles somebody could take offline. So, there we go. So once I've been able to allow it for export, I would just publish my service from there. I think that's, yeah.
Okay, so that was preparing data for offline use in ArcGIS Online and ArcGIS Enterprise. The other way of preparing your data for offline use is obviously in ArcGIS Desktop. And there's a couple of options here. There's actually a few different layer types that I missed from a previous slide. I've since added them to that slide for the next time around. But there are other layer types that you can just package. We've talked about mobile map packages, and that incorporates the map and their layers. But at this point, we're just talking about layers on their own, because there are some layer types that you can prepare in ArcGIS Desktop just at the layer level. And those are scene layers and scene layer packages. So for use in a 3D scene, you can actually create an individual package containing a single layer, a single scene layer type of various types, integrated mesh layer, for example. And you can actually just create a scene layer package, and then you can open that up in your application in a runtime app with version 100. You can also create raster layers. You can either work with raw raster files that you've prepared in some other package, software package, or you can prepare those in ArcGIS Pro. And you can also use a geoprocessing tool in ArcGIS Pro to create a mosaic dataset and convert your existing file geodatabase mosaic datasets to mobile mosaic datasets that live inside a mobile geodatabase or a SQLite geodatabase. So you can actually create individual layers at that level too and use those with version 100 of the runtime. That's using this kind of layers that you can create in Pro. With ArcGIS Desktop, you can still do the local server workflow where you're creating map packages and adding your file geodatabase or shapefile inside that. That's the only way that you can work with enterprise geodatabase connections. Local server only runs on desktops, so it doesn't run on Android, on iOS, or Mac. It only runs on Windows and Linux. But that workflow is still available for you, and when you create map packages, you can also integrate geoprocessing tools into that too. And then there still is the create runtime content that is compatible with Quartz version 100. You can still do that, but we recommend you to work with mobile map packages because that allows you to save a lot more information into the map itself, such as bookmarks, layer, order, render overrides, and things like that. So that's really how you would prepare offline layers with the desktop products. Okay, so we've talked about working with maps. We've talked about preparing your data and the layer types you can create. Now let's look at how you actually use those layer types in your application and bring them to life. So when you're working with Basemaps or tiled layers, essentially if you've pre-created a tile cache, either if you've exported your tile cache on demand or you've created your tile cache in ArcGIS Pro, you essentially instantiate a tile cache object that has a little bit of metadata about it, like a thumbnail and a description and a spatial reference. You can use that to instantiate an ArcGIS tiled layer, and that works like any other connected ArcGIS tiled layer. So we're trying to make the online and the offline coding patterns essentially the same. So it's the same layer type, it's just you construct it with a tile cache, which is from a path rather than from a URL. So it's pretty simple to work with tiled layers in online or offline scenarios. If you want to actually create the tile cache through calling export tiles on a service that's been enabled that you just saw Justin configure, you use our export tile cache task. It's the pattern of working with this task is exactly the same as all our other tasks. You construct it with a URL. It's a loadable object, so you can load it. That then allows you to generate default parameters. Generating the default parameters is actually an asynchronous method. So if you haven't loaded the task and you call that, we'll load it for you. You can then add in a few of the properties that you want to those parameters, such as the level of details and your area of interest. And then you can use those parameters in the operations for estimating a tile cache size or exporting a tile cache. And these actually return you jobs, which you then start, and then you can monitor the status of those jobs. And you can pause those jobs and save them to disk, and then rehydrate them and kick them off from where they were going last time too. So that's working with tile caches. Pretty straightforward, and pretty much the same as in 10.2x too. In terms of working with operational layers, let's just get that. You work with feature layers and feature tables, and typically as a developer you're going to be programming against the ArcGIS feature table, and again that unifies the online and the offline workflows. So if you're working with a URL and an online workflow, you're working with a service feature table. If you're working with an offline geodatabase, you're working with a geodatabase feature table, but they both inherit from ArcGIS feature table, and that's really the class that you'll be using for doing the majority of your logic. Adding, updating features and querying features are all kind of at the feature table or the ArcGIS feature table label or above. So that's how you kind of consume these geodatabases, however you've got them. In terms of creating geodatabases, you use the geodatabase sync task, which is what Justin was trying to say earlier.
I did. Generate method from the geodatabase.
Well, that sounds like an excuse. And you create one of those tasks with a URL. It's a loadable. You load it. Once you've loaded it, you can create default parameters using the create default generate geodatabase parameters async method. That's really catchy, but.
And he wonders why I had a problem remembering what to call it. Yeah.
You will notice some of our naming is a little long, and we've done that on purpose, and we've decided to make it explicit so that there's no ambiguity. So it's difficult for us to say it, but as a developer, when you look at that method, you do know exactly what it does, which is very useful. So we've very much we didn't want to shorten and add in acronyms because it might confuse people, so we've done that. That's definitely on purpose. So create the task, load it, create the parameters, and then you call the generate geodatabase method, and that returns you a job, and then you start that job, and that allows you to then monitor the status of that job, and the job will return and give you the result, which is a geodatabase at the end of it. So that's how you work with the geodatabase sync task in terms of generating geodatabases. If you want to sync the geodatabase, obviously we'll go into much more detail about this tomorrow in the editing session, but sync is still relevant for when you're creating geodatabases because you want to make sure you've got the latest data. Even if it's just pulling the data down and you're not doing edits, you still want to synchronize that geodatabase to make sure you've got the latest data. Pattern's exactly the same. You create a new geodatabase sync task, you create the default parameters, you create the sync geodatabase method. Yeah, we probably should have called that synchronized geodatabase if we were going with really long names, but I think sync's fair enough. It creates you a job, you start that job, you monitor for its status, and when it completes, the geodatabase has been synchronized and you've got the latest data in there. So that's the kind of pseudocode. Best thing to do, of course, is to hand over Justin for a demo.
All right, we can make this one really quick. So, I'd like to go to number 4 first. So here we're actually looking at the iOS sample application. So this has a whole bunch of different samples for a bunch of different feature functionality in the app. So it's a great place to go to explore and find out the capabilities of the runtime. And specifically, if you're a Swift or iOS developer, it's a great tool. So one of the samples that they have there is the offline edit and sync example. And so from here, I have a simple wildfire service that has some great test data on it, and we want to take this data offline. So we're going to hit the Generate Geodatabase button. And one of the things that you need to do when you're taking your data offline is define the extent that you're going to take. And maybe I shouldn't edit. We're going to define the extent that we want to take offline, and we can also choose which layers from the service we're going to take offline as well. And for right now, we'll just do the points layer, but we could do multiple ones. And I click the download button. So behind the scenes, this is going out. This is making a generate geodatabase call to the service, giving it the parameters that we set up. And when it finishes, it will be downloading a geodatabase file and putting it on disk where we've told it to save. And I'll skip the sync part because tomorrow Will's going to demo all of that stuff, and we'll go into a lot more detail about that. If we just quickly take a look at the code here, we have our generate geodatabase. This is very similar to what Will was talking about. Will kind of showed the pseudocode of what it looks like across all of our runtime APIs, and then this is the particular implementation inside of Swift. So instead of using the default, generate the default params, we actually created a parameters object and then set some of those specific things that we were looking at. So we set our extent, we set layer option, because this is where we wanted to define that we only wanted to take one of the layers offline, and we said that we did want to get our attachments back for any of those layers. Set up the path of where the geodatabase is going to be saved to, and then we get our generate geodatabase job. And from there we can call start on the job, which actually goes off and kicks off the request to create and download the geodatabase. We'll take a quick look at the sync code. Very, very similar. Again, this is following our task-based pattern that we're using throughout the API. Created our sync geodatabase parameters object, set up the layer options that we wanted to use in terms of what we were going to sync, created our sync job, and started the job. So that would have taken care of doing our synchronization, pulling down any new changes from the server. So.
Good. Okay, so we've seen we talked about the workflows. We've talked about working with maps, how you create them, how you bring them down and work with them in the runtime, how you save them. We've talked about layers, how you prepare the services and the data, and how you bring those layers to life in your application. And that's pretty much the workflow that you as a developer would have to do. So that's pretty much the majority of our talk. There's a little bit slide on licensing. I suppose the licensing model with version 100 has changed. In 10.2x, we kind of separated online workflows and offline workflows, and we kind of made the licensing so that you had to purchase, license the offline workflows. We've actually changed that, and we've now made it for version 100. We made it so that we've separated the capabilities, whether they're online or offline. So now viewing and opening and working with maps from the platform, whether online or offline, is at the same licensing level. But then the next licensing level up of basic is really where you start to edit and edit your data. Again, whether it's online or offline, it's the same. So from an offline workflow point of view, if you're just not doing editing, then actually the situation right now is with version 100 is better than it was in 10.2x, which is great. So if you want and have questions about licensing, we'll get David or Euan to answer those questions. Okay, so that's pretty much where we're at with version 100. What are we working on for update 1? So update 1 we're working on is going to be out sometime before the user conference. It's got a lot of new capabilities in there, especially related to working with maps online and offline. We actually are building the offline map task. Very close to being done. You'll be able to see demos of that in the Road Ahead session, which I think is tomorrow. And this actually means that you as a developer don't need to work at that layer level. So it means that my slides next year should be a little bit more concise and a little bit easier to demonstrate. And it makes your life easier too, because you'll be able to work with a map and just call one operation to take that map offline. We'll figure out all the layer types for you. We'll figure out what tasks to create and how to synchronize those, and we'll save the map locally for you as a mobile map package, and then you as a developer will just be able to open that map. So that will get a lot better in update 1. We're adding a few things to mobile map packages themselves in terms of adding them in Pro and adding them in Runtime, in terms of being able to search for features, work with bookmarks, work with related tables, and be able to add in raster-based tile packages. Right now in Pro, you can add in vector tile packages, which is really cool inside a mobile map package, but you can't add in raster tile packages. So if you want to add imagery to a mobile map package right now, you can't do that, but we'll be working on adding that into Pro 2.0 and then into the runtime. In terms of beyond update 1, the other things related to working with online and offline maps is being able to edit mobile map packages and edit the data inside them. We're looking at how we might want to do that. And we're obviously also working on the ability to open and edit web scenes. Right now you have to construct scenes as a developer, and we can't open web scenes, but we're going to do that in the same way that we're working with web maps going forward. So we'll hopefully have that for you soon. So that is pretty much the end. bang on 2 o'clock, which means we're a little bit over time because we haven't left time for questions, but I'm going to ask whether anyone's got any questions anyway. Any questions? Yes, sir.
Is the mobile map package version example available on GitHub yet?
The map book example app. So the question is,
The mobile map package.
the one that we showed in this, not yet, but it will be. So the question is the map book demo app that we built today on GitHub? It's not yet, but it will be very soon. It's an example application that we're putting out there. We'll put the whole repo up there and write documentation around it too. So it will be there soon. Any other questions? One at the back there.
I have the examples you showed there was pretty much it looked to me like a pull map packages from the server.
Yep.
How would you go about making more like a push
Put from the app.
from the server to the if I want to send specific map packages to specific units or users?
Okay. So the question is, the MapBook app we showed how we could connect to the portal and pull down packages. I think the question is there a way that you'd be able to push packages to a client? You could, yes, absolutely. Brilliant. I think if you did want to push data down, you'd have to look at some of the push notifications frameworks for mobile platforms and for Windows to figure out how you want to do that. But you've got to remember that the mobile map package payload is potentially quite large. That's not the sort of data you want to push to a device unnecessarily and without the user necessarily wanting to accept it. So for these large data files, it's certainly something you could do. And then pull, yeah. So you could push a notification to say it's been updated, go and get the latest, and then require the user to click OK, and then it download it, for example. Because you want to make sure the network connectivity is there for long enough for that full data stream to come across, and that might require a bit of synchronization. But yeah, certainly something you could do. Any other questions, quickly? Last one.
What about what was the size of that MacBook app that you did? The map package and all that?
So the question is, how big is the
33
MacBook app? You can ask Mike Wilburn, who edited the package. He's right there.
I want to say it was about 40 megabytes.
About 40 megabytes. That's for the mobile map package itself, correct? And then the app, there's obviously app code on top of that and libraries on top of that. And the Android library runs at about 30 meg for just our static library in the Java code. Okay, I think we're done. Thank you very much. Any more questions, you can come and speak to us afterwards. Thank you.